Today we're starting DMA40. DMA40 is our beginning section on algebra. We are going to be working with expressions. We are going to work with linear equations, and we're going to work with inequalities. Inequalities are actually going to be solved the same way as our linear equations. The only difference is instead of having an equal sign, there's going to be a greater than or a less than sign. As we work in this module, we're going to have the introduction of what are called variables. Variables are placeholders in an equation. Examples that we might use for variables, it would be any letter of the alphabet. Oftentimes you'll see an X, an M, a P, a Y, a Z. Now when I do Z's, I always put like a little tick mark through it. You're going to see a variety of letters that are going to be used as placeholders. They represent a number we do not know. They represent a number we do not know. Our goal is going to be one of two things. Either we're going to be given a value to plug in for it and simplify an expression, or we're going to solve the equation to find out what that solution actually is. Let me give you some examples of algebraic expressions. Some algebraic expressions would be such as algebraic expressions. It could be something such as x squared plus 3x minus 4. It could be x plus 2. It could be negative 7m. It could be 4x minus 8. It could be anything that's going to have variables. So you're going to have variables. You're going to have numerals. And then you're going to have either an addition, a subtraction, a multiplication, or a division. You will have one of those operation signs that will connect the different terms of the algebraic expression. When you evaluate an algebraic expression, you will plug in values for the variable, then you will simplify. So let me give you an example. An example that you might have would be, let's say, 7x. And if I tell you if x is equal to 2, what that means is we have 7 times 2, because a number and a letter side by side means multiply. So this would mean to multiply. So 7 times 2 would simplify and give us 14. If I were to give you, let's say, 2 and then x minus y, and if I tell you, let's say, if x is 10 and y is 4. So that would be 2 times 10 minus 4. 10 minus 4 would give me 6, and 2 times 6 would give me a solution of 12. So when you evaluate an expression, you're going to plug in the value they give you to represent for that letter. Now, sometimes when you evaluate an expression, the value might be a negative. So let me explain how that is going to work. In this particular expression, we're going to say that x is a 3, and we're going to say that z is a negative 5. So that would mean we're going to have 4 times the 3 is going to be squared minus 2 times if z is a negative 5. So as we simplify this, 3 squared, 3 times 3 would give us 9. So we have 4 times 9, and I'm just going to recopy what we have here. 4 times 9 is 36. Those get multiplied. This we're going to treat as negative 2 times negative 5. Negative times negative gives me a positive 10. And 36 plus 10 is going to give us 46. Now, in order to check this, I highly recommend use your calculator. So if we're going to use our calculator here, we're going to have 4 times 3 squared minus 2 times, down here we use the negative sign, negative 5. And that will check for us, and we get 46. So when you have your expression here and you plug in the value, you can work it longhand as I've shown you, or you may come to your calculator and key that in. So expressions are usually just going to be something that is simplified. Let me give you a different example. We'll use a different color here. Let's say we have 8x minus 3z. Well, let's do 8x plus 3z. We'll do it that way. So in this case, what we would have is 8 times 3, because my x is still 3. My z is a 5, so that's plus 3 times negative 5. 8 times 3 is going to give us 24. 3 times negative 5 gives us a negative 15. And 24 minus 15 is going to give us 9. So here you're going to type in 8 times 3 plus 3 times negative 5, and that's going to give you your 9. So evaluating an expression is plugging in a value and simplifying that expression. Now, when you see the word equation, what I want you to do is to notice these letters, EQUA. That should remind you of the word equals. So an equation is going to be a statement that has an equal sign representing that two expressions are equal. So it is a statement with equals to show both sides, to show both sides of the expressions are equal. So an example that you would see with an equals could be if you have, let's say, 5x equals 20. Okay, so that means the left side 5x is equal to the 20 on the other side. Later on, we're going to learn how to solve this. We're not going to talk right now about how to solve it, but what I'm going to do is ask you if a certain number is a solution. So I want to know if 2, 4, and 10 are solutions. So in this section, when you're given an equals, they're going to give you values to substitute for the x and then determine if it is equal, if it is an answer or a solution. So let's start with the 2. I'm going to do the 2 in red. So that would give me 5 times 2 equals 20. 5 times 2 is 10. Is 10 equal to 20? No. So the 2 is not a solution. So I'm going to mark that out. That one is not a solution. Let's do the 4 in purple. We would have 5 times 4 equals 20. 5 times 4 is 20. 20 is equal to 20. So yes, the 4 is a solution. Let's test the third number. They gave us a 10. So that would be, that would be 5 times 10 equals 20. Well, 5 times 10 is 50. 50 is not equal to 20. So that would not be not a solution. So in this section, as you're dealing with equations, they're going to have you substitute a value for the variable. You're going to simplify the left side, bring down the right side, and then you're going to see if those last values are equal to each other or not. This first one is not, this one is not. So the only solution would be the 4. The other two are not. What I want you to look at in your book is on page 4-7. This is where you're going to find a list of terms that are going to help you. When you are writing an algebraic expression, you will need to use these words to help you determining what you're going to use for addition, subtraction, multiplication, division, and equals. Some of the most common and the most basic words for addition would be the word sum. For subtraction, you're looking at the word difference. For multiplication, that word is product. And for division, that would be the quotient. This would be your equals. Now there's many other terms, and these words are represented on page 4-7. So you would have sum, you might have total, you might see the word increased by, plus. For difference, you might see the word minus, you might see less than, you might see the term subtracted from. For product, one of the words that normally is sort of a surprise is just the word of, an amount of something else. Generally, that's going to mean you will be doing multiplication. You may see the word times. If you see the word twice, or if they tell you to double, triple, quadruple. Quotient, you will also see the word divide or divided by. You might see the word ratio, which that's familiar from dma040. And we did division when we had things written as a ratio. We also talked about the word per. Per would also mean to divide. If you were asked about half of something, you would divide by 2. Other keywords for equals could be is, gives, yields, is the same as. So you might see a variety of terms representing equals, okay? So what we're going to do, and I'm going to look at what's in your workbook so you have something to go by. On on page 4-8, you have several statements here, and you're being asked to write these as an algebraic expression using x as the variable. So if I were doing the first one, it says twice a number. Twice a number we would represent as just 2x. It means 2 times x, but when you are doing problems in algebra, instead of doing, do you see how if you wrote 2 times x, that could look confusing? When I write this, I make my asterisk, my time sign look like an asterisk. You might see 2 with a dot and then the x. That's another possible way to do it. But the preferred way to write this is going to be a 2 with the x directly beside of it. We're not going to normally put a time sign or a dot between a number and a variable. They'll be touching. The next one I have is 6 less than a number. 6 less than a number. Now, let me write that down. 6 less than a number. So, if you wrote down 6 and then put minus and then the x, when you look at this, does this mean 6 is less than the number? This says 6 minus x, or x is less than 6. So this one would not be correct. The 6 is less than is being subtracted from the number. So 6 would be less than the number would then go in front. This one was twice a number. Okay. Let's go to the sum of twice a number and 3. Okay, sum means we're going to add. The sum of the first term is going to be twice a number. We just did twice a number, that would be 2x. And we're going to add it to the number 3. The difference of 7 and a number. Difference means we're going to be subtracting. And this one is not telling me to rearrange it in any order. So when they start with difference of 7 and a number, we're just going to subtract 7 minus the x for the number. 4 subtracted from 3 times a number. Okay, if 4 is being subtracted from, that means you're going to have a minus 4, and then there needs to be a number at the beginning. So what goes at the beginning is going to be 3 times a number. 3 times a number is going to be represented with 3x. And that is all of our section 1. Section 2 talks about properties of real numbers. Properties of real numbers. So we're going to take a moment and talk about these several different properties. The first property is the commutative property of addition and multiplication. This property applies to both. It's either all going to be addition or all be multiplication. So that means, in other words, if you have A and you add it to B, that would be the same as having B and adding it to A. You can change the order. For the multiplication part, it would be A times B is the same as B times A. So in this case, what it means is changing the order does not change the answer. So let me give you an example. If we have 2 plus 5 or 5 plus 2, 2 plus 5 is 7, 5 plus 2 is 7. We still have the same value. We can change the order. If it's multiplication, we might have 5 times 4, or we could write 4 times 5. 5 times 4 is 20. 4 times 5 is 20. It gives me the same value. So that's the commutative property, is that you can change the order of something if they're being added or multiplied, and you'll get the same solution. Does not apply to division and subtraction, only addition and multiplication. The next property is the associative property of addition and multiplication. For the associative property, it means changing the grouping of the numbers does not change the answer. An example of that would be if we have A plus B plus C. Let me write it 2 times here. Associative, when we associate things, we group them. So if I were to group A and B, I'm still going to get the same answer as if I had grouped B and C. The same thing applies for multiplication. If you have A times B times C and A times B times C, we could group the first two, or we could group the last two. Let me give you an example so that you can see that this is true. If I were to have 1 plus 2 plus 3, 1 plus 2 plus 3, I'm going to group the first two, and here I'm going to group the second two. 1 plus 2 is 3, and 3 plus 3 gives me 6. Here, I have to group the 2 and 3, so 2 plus 3 is 5. 1 plus 5 is equal to 6. So I'm going to get the same solution. If I did this and I had, let's say, 2 times 4 times 5, I'm going to group 2 and 4, and then I'm going to group 4 and 5. 2 times 4 is 8. 8 times 5 is 40. Here I would have 2. 4 times 5 is 20. 2 times 20 is 40. So no matter which way you group them, you're going to still get the same solution. And the parentheses are what we use for the grouping. So commutative is order, associative is grouping. The next thing that we have are the identity properties. Identity properties. So for addition, what can we add to a number and still get that same number? We can always add a 0. For multiplication, what can we multiply something by and still get the same number? We can multiply anything by 1. So if I substituted some values here, and let's say I had 2 plus 0, my answer is 2. Here, if I had 5 times 1, 5 times 1 is still 5. So the identity property is that we can either add 0 or times by 1, and we would still have the same answer. The next concept that we jump into is when you see the term additive inverse. Wait a minute. Additive inverse. The additive inverse adds up to a 0. So The additive inverse, in other words, is going to be the opposite. So if I were to have that 2 and I wanted to have something equal to 0, what I would add to it would be a -2. It would be the opposite. The additive inverse is the opposite number. If I had had a -7, I would add to it a +7 to get the 0. For a multiplicative inverse, the multiplicative inverse is when you multiply to get a 1. Multiplicative inverse multiplies to give 1. The term that we're going to use here is going to be the reciprocal. The reciprocal of a number is when you, in essence, flip it. So if I were to give you a 3 and I need to multiply it by something to get a 1, this 3 technically would be over a 1. So the multiplicative inverse is going to be, if I flip that, that will become 1 over 3. 3 times 1 is, right here, 3 times 1 is 3, 1 times 3 is 3, and 3 over 3 gives me the 1. So a multiplicative inverse is simply flipping the number that you have. If it's already a fraction, you just flip and reverse the numerator and denominator. And the last concept, which actually is my favorite concept, and you're going to be using this a lot, is the distributive property. This is a big basis of what you're doing in algebra and with your math beyond this DMA. The distributive property, an example that we could have would be as if we have A times B plus C. What that means is we're going to multiply the value in front times what's inside the parenthesis. So in other words, we're going to multiply the A times the B, and we're going to multiply the A times the C. That gives me the AB and then the AC. So if we have an example such as 3 times x plus 4, what I'm going to do when I distribute is I'm going to multiply 3 times x, that gives me 3x. Then I'm going to multiply 3 times positive 4, that gives me a positive 12. And then that would be my solution. Let's do another. Let's say I have a -2, and then let's say I have 5m minus 9. Okay, so when we distribute, we're going to multiply. I'm going to multiply -2 times 5m. Negative and positive is a -10m. And then I'm going to multiply -2, treat it as -9. Negative times negative is a positive. 2 times 9 is 18. So you're going to distribute the number in front by what's in the parentheses. Sometimes you may have a problem where there's just a negative sign in front of a parenthesis. We might have 8x plus 4v minus 3z. In this scenario, what happens is where that negative sign is, it's understood to be a -1. So we're going to distribute a negative times each term. Negative and positive gives me a -8x. Here, negative times positive gives me a -4v. On my last term, negative times negative gives me a positive 3z. So if it's a negative sign alone in the front, it's going to change the signs of everything that is inside of the parentheses. Sometimes you may have numerals. Let me give you one because I know you're going to think this one's complicated, but it's not. If you have one that has a fraction, we're going to have -5/6 times 12a minus 18b plus 6c. This is not meant to be difficult. We're still going to just distribute. So you're going to use your calculator just to make the math part, the fraction part, simple. Negative 5/6 times 12. So we're going to do negative the fraction 5/6. You have to move it to the right and then times 12. That gives me a negative 10. So my first term is negative 10a. Then I'm going to do negative 5/6 times negative 18b. So that will be negative 5/6 times negative sign 18. That gives me a positive 15. So that's going to be plus 15b. And then last, negative 5/6 times 6. So negative 5/6 times 6 gives me a negative 5. So that would be minus 5c. And you're done. So with the distributive property, don't fret if you see fractions. Do not fret if you see negatives. You can use your calculator to do the math, the multiplication. And when you're doing the distributive property, the three things to keep in mind. First, know that you're going to multiply. Ask yourself, what is the sign? The next thing you're going to have is the number. And then, is there a variable? Is there a letter? So you're going to multiply. Ask yourself, what's the sign? Write down the number after you've multiplied, and is there a letter? If there is, you include it. If there's not, then you don't use one. And that would be it. That is the end of section 2. So that gets us through the first 2 sections of DMA 40.